All right, 9:30 students, we are back with another day of linear inequalities, 2.11, day 2. So let's jump right into it. My warm-up asks if the point 5, -2 is a solution to the inequality 2x minus 3y is greater than 16. Let's find out. I'm going to start by labeling my x and y for the pair. And then I'm going to rewrite my inequality with those values in. So I rewrote using x and y. Now I'm going to calculate 10 minus -6 greater than 16. Well, I know that minus a negative becomes plus a positive. So I'm asking, is 16 greater than 16? No. 16 is equal to 16. So that's a good example of what we talked about yesterday, right? Like that dotted line does not work because those answers are not true. This is a good example. 16 is not greater than 16. It's equal to 16. But since we don't have that symbol there, it cannot work. We're going to work on showing algebraically if the points are a solution for the equation. So we're going to do this just like we did in our warm-up. We're going to substitute in our x and y, and we're going to decide if they make a true statement. So in this equation, I would do 3 times 4 plus 2 times 2 and decide if that's going to be greater than 12. 3 times 4 is 12. 2 times 2 is 4. Is 12 plus 4, 16, greater than 12? Yes, it is. So yes, this is a solution. It does check out. Okay, we have to graph the solution set for 2y is greater than 4. We need to get y alone so that we can graph. When I do that, I get y is greater than 2. Okay, I do not have an equal to, so this means I'm going to have a dotted line. I know that y's are horizontal lines, so I'm going to go up to 2 and make a horizontal dashed line. All right, next thing, I see that it is a greater than. Where is y greater than 2? And it's going to be above. So I'm going to shade everything on the graph above. Now it asks me, is the point 1, -1 a solution? Nope. Is the point 3, 0 a solution? Also no. And is the point 4, 2 a solution? Nope. Dotted line. Not equal to. Does not work. All right, we have a 3x is greater than 6. Let's divide by 3. X is greater than 2. All right, I know that x equations are vertical lines, so I'm going to go to 2. And again, I have another dashed line because I'm not equal to. And it's also x is greater than. Well, let's think about it because it's a little different than my y's. Where are the numbers greater than 2 on the x-axis? And that is to the right. So I'm going to shade everything to the right. Then we're going to talk about our solutions. Is 1 -1? Nope. Is 3 0? In the shaded, so yes. Is 4 2? Also in the shaded, so yes. Last one we have today says that Francesca can spend at most $6.75 on healthy snacks for a party. Veggie chips cost $1 per package and grapes cost 75 cents per bunch. The equation is graphed. Find 2 combinations of veggie chips and grapes that Francesca can buy. So it could be anything within the shaded area, right? These are any of the solutions. At most also means equal to. So we could actually use our equal to or anything on the line. So you could say like two bags of grapes, and 2 bags of chips. You could pick any solution that is inside this shaded portion, inside the shaded graph. And that's it for today's lesson on our second day of inequalities. Make sure that if you have any questions, you go ahead and send a quick email to a teacher and ask for help.